Thank you for joining this lesson. We're going to discuss transformations. Number 19. The triangle x prime, y prime, and z prime is the image of x, y, z under a rotation. On the grid provided below, draw the triangles x, y, z and x prime, y prime, z prime. Remember to subscribe and to share this link with friends. Let me start by drawing x prime, y prime, z prime. So 1, 0, the coordinate will be found here. That is 1, 0. The coordinate will be our x prime. Then y prime is 0, negative 3. So 0, negative 3. The coordinate is going to be here, y prime. We also have another coordinate, negative 2, negative 1. So negative 2, negative 1. The coordinate will be here, z prime. Let me first of all connect these triangles so that we may get the image. So that is the triangle, and actually the triangle image. We can talk about the triangle xy prime now, or xyz. 3, 2. So we have 3, 2. This is where x is. The next is 4, 5. So 4, 5. This is where it is. And z is a 6, 3. 6, 3. We found here. That is our z. So now we can connect them using very straight lines. So we have our two triangles now here. A triangle and its image under a certain rotation. A good thing, we've already been told that it is a rotation. So what do we do first? We connect points and their images. Then we perpendicularly bisect the lines joining them. For instance, let me change my color. Can use some green now. We can talk of x and x prime, which are found here. That is x and x prime. Then we perpendicularly bisect now the line joining them. We perpendicularly bisect this line joining x and x prime. Therefore, the perpendicular bisector is going to be here. The perpendicular bisector will pursue through there. Right. The next is we connect y and y prime. Connect y and y prime. So y prime can just be connected that way. Then again, we do a perpendicular bisector to the line connecting y prime. So we bisect it perpendicularly. So y prime, let me show you where the perpendicular bisector will pass through. So this is the point. That is where the perpendicular bisector will pass through. So we do a perpendicular bisector through that point. Yes. Then again, we can talk of z prime. So z can be connected to z prime. Then again, we do a perpendicular bisector to this. Perpendicular bisector to this is going to go through here. So we raise the perpendicular bisector through that point. This is now confirming that all the perpendicular bisectors are meeting at a point, and the point is 2, 1, the coordinate 2, 1. So the center is 2, 1. That is the coordinate of the center of the rotation. The other thing is the angle of rotation. So for us to know the angle of rotation, now we have to connect. Let me change again my ink. Can use this color such that because I want the angle of rotation, I can connect now y to the center, then to y prime. Y to the center, then to y prime. So from y to the center, then to y prime. The angle which has been moved there is either from this center now is either a negative 180 or a positive 180 because the two transformations are just the same. Again, we can connect Z and Z prime to the center. So Z can be brought to the center, then proceed to Z prime. And again, we can confirm that the angle here is either a negative or a positive 180. So the angle is either positive 180 degrees or negative 180 degrees. They are one and the same transformation because when you go to the clockwise through 180, when you go to the anti-clockwise through 180, you just get the same thing. The question continues to take us to part C. The same axis, draw double prime, the image of the first image, and a reflection in the line y equals to x plus 2. For this mirror line first, we give it what we call a table of values, such that with x values, can start at a value like 2. When x is 2, y should also be 2. When x is 1, y should be 3. When x is 0, y should be 2. So we can get this mirror line. 2, 4, 1, 3. So 2, 4, then 1, 3, then 0, 2. The line passes there. So we can first of all draw it. The mirror line. So the mirror line has been drawn now. That is where we are going to reflect the first image. So we connect the points using very straight lines to the mirror line. Then we proceed an equal distance to the other side. If it's Z, we connect Z to the mirror line. Then we move an equal distance to the other side, such that if this is Z prime, now Z double prime is going to be here. So this will be Z double prime. We again connect X prime to the mirror line through a perpendicular line. Then we move an equal distance to the other side, such that if this is X prime, then X double prime will be at that point. We do the same for Y and Y prime. So for Y prime, I think we are moving now along the same line. So that one has been connected. So we move to the other side now. So this is where if you move an equal distance, you discover that Y double prime will be found at that point. And now we have to connect now. Now we have to connect. This is now the triangle, the second image. So that is where it is. We have also been advised to list the coordinates. So to list the coordinates, x double prime is going to be negative 2, 3. Y double prime, then z double prime. We're going to have y double prime as negative 5, 2. Negative 5, 2. Then z double prime is going to be negative 3, 0. Negative 3, 0. So those are the coordinates. And finally, triangle with a triple prime, the image of the second image and an enlargement, center negative 5, 0, and scale factor positive 2. Negative 5, 0. Negative 5, 0. So the center is here, negative 5, 0. This is negative 5. So negative 5, 0 is going to be here. So we're going to connect. We're going to connect all the points. Sorry, negative 5, 0. I think I've not identified it well. Negative 5, 0 should be here. Negative 5, 0. This is the center now of the enlargement. So to enlarge, we just connect all the points to the center, such that to the center of enlargement. So we're going to connect, if it is x double prime, to the center here. So we do a straight line. Then now we're going to move an equal distance from the center to where x is. Then we move again to the same side an equal distance, because it should be to the center 2 times. So when you move like that, though the scale is not allowing us to carry out the enlargement, you're going to get the enlarged triangle. You repeat the same for z prime and y prime. You connect to the center, and on the same side the object is, that is where we should find the image, specifically when the scale factor of enlargement is a positive, like our case in this case.